Autobots rollout. Let's. It'll get better. It'll get better. I promise. Shh. All right. So this is confidence intervals, day 2. That's what the 2 is going to indicate here. So our confidence intervals, the whole logic of them is based on that sampling distribution, and so I have to I have to meet some criteria to know that I've got the sampling distribution that I'm talking about. So I have conditions that I need to meet, and my conditions are: number 1, I need a simple random sample of my population. We will, of course, abbreviate that SRS and not write those words out ever again. I think I said that the last time I wrote those out. So that's required because my sampling distribution is a sample of all distribution of all possible samples. So I want any possible sample of size n to have an equal chance of being chosen. I'll get that with a simple random sample. Condition number 2, I need my sampling distribution to be approximately normal. And what things will give us an approximately normal sampling distribution? We got a bigger sample size than 35. What else? Okay, for proportions, if n times p and n times 1 minus p is greater than or equal to 10, there's something else that gets us an approximately normal sampling distribution. If the population was already normal to begin with. Okay? So that's like the first thing we would always want to check. And my third condition, my observations must be independent. Must. So, independence. So I need to, I need to make sure that the first person that I ask in my survey isn't telling the next person what they should be answering. I need to make sure that when I ask people or when I measure people, that those measurements aren't influenced unduly by other people in the survey or by me. Yes, sir. What do I mean by confidence intervals aren't probabilities? They don't tell me, once I've made the confidence interval, they're not telling me the probability that the word length of that book is between 4.99 and 5.07 letters per word. They're not telling me the probability. They're telling me the proportion of all possible samples that will give me an interval that will contain the real answer is 95%. Okay, so it's a real distinction there. It's one of those you kind of got to get clear on, and there's always like a little trick question on the AP exam about that. Otherwise, it's not so important, except that they try to trick you. Okay, for observations to be independent, we also could be out sampling from a large population, and when I go out and I do a survey, I don't ask the same person twice. So essentially, I am surveying without replacement. I'm sampling without replacement. If I sample without replacement, if I take one card out of the deck and don't put it back in, I'm into conditional probabilities. But if I've got a great big population, 100 million people, and I ask one person, and I don't put their name back in the hat, what's the difference? I probably won't ask them again. So I sample without replacement if I sample from a large population, and that way I still get independence. So a check for independence would be to sample without replacement from a population that's at least 10 times bigger than the sample size. So those are conditions I have to meet. That will be one of the many pieces one of the 4 pieces of our inference procedure that we're going to learn today. How exciting. All right. So we're going to formally do a confidence interval. So a confidence interval in general is defined as your estimate of your population plus or minus your margin of error. But more specifically, more specifically, our estimates are mostly going to be means or proportions. Another call came in. Nice. Really. Plus or minus the number of standard deviations times the standard deviation of your sampling distribution. Now we're going to do a mean today. So I'm going to simplify this into, my estimate will be my sample mean plus or minus the number of standard deviations. We're going to abbreviate with Z with an asterisk, and that's called critical Z, and we'll learn how to find critical Z here, times the standard deviation of the sampling distribution, which in this case is probably going to be sigma divided by the square root of n. Okay? Yes? Yes, sigma is still population standard deviation. We'll only use that for a few days, and then we will get into a different distribution that will allow us to use the sample standard deviation. That'll be the t distribution. The first procedure you learn, you probably won't ever use again, but it's the simplest. Okay? And you may not say it's the simplest once we get all the way through this, but we shall carry on. All right, first, you know what the sample mean is. You know almost everything in here except this Z star. So this Z with the asterisk is called your critical Z, and it is defined as the value on the horizontal axis of your standard normal distribution